You stand on the edge of the known universe, or at least humanity's reach into it. The year is 1977. The California desert air is hot and still, but a deeper quiet hums beneath the surface, the silence of infinite space. Your gaze is fixed on a titan of a rocket, poised on its launch pad, a slender finger pointing toward eternity. Inside its payload bay, something waits. A gold-plated phonograph record etched with the sounds of Earth. A baby's cry, a whale's song, the laughter of children, greetings spoken in 55 languages. Humanity's portrait, a cosmic invitation, sent spiraling into the eternal night. A message cast into an ocean vaster than imagination. You wonder even then if anyone would ever find it, if, after decades, centuries, millennia, anyone would ever answer. Hold that image in your mind. The audacity of hope, encapsulated in gold. The profound wonder of daring to announce our presence to the universe before we launch ourselves deeper into the incredible story unfolding right now, in our present moment. A quick word. Wherever you're listening tonight, London, Los Angeles, a quiet room in Lagos, or perhaps a cabin nestled deep in the Himalayas, welcome. Welcome to Sapiens Untold, where we explore the most enigmatic chapters of our shared human story. Where are you listening from tonight, and what time is it where you are? Settle in. Get comfortable. Dim the lights if you can, and let your mind drift into the cosmic mystery. If mysteries like this pull at you the way they pull at me, hit like and subscribe to join our growing community of fellow cosmic explorers. Now, let's step forward. 48 years into that cosmic silence. To October 29th, 2025, tomorrow. The cold is absolute. You feel it in your bones. A vast, pervasive chill that precedes the light from any star. Around you, the blackness of interstellar space is not empty, but a canvas where distant galaxies hang like smeared fingerprints of creation. This is where Voyager 1 travels, 15 billion miles from home, a tiny, defiant spark of human ambition. It is the loneliest object forged by human hands, carrying within its metallic shell not just instruments, but a golden phonograph record, a time capsule, a beacon, a desperate plea into the cosmic void. For decades, that message has been racing outward, a ripple in the fabric of existence. Every whisper, every broadcast, every television signal humanity has ever produced forms an expanding bubble, a spherical shell of radio waves screaming, "We are here," into the galaxy. It is already 95 light-years wide, touching distant suns, fading yet persistent. You ponder the sheer audacity of it. An entire species, so young, so fragile, yet so eager to be known, to break the profound silence that permeates the universe. We sent our best music, our diverse languages, our very location etched into that gold, knowing it would outlast mountains, perhaps even stars. What did we hope for in that boundless dark? A friendly wave? A shared conversation across the void? Or simply the knowledge that we were not utterly magnificently alone? 40 years. The journey continued. 40 years of that golden needle spinning in the silence, waiting for a stylus that might never arrive, for ears that might never hear. A generation grew up, lived, and passed without a single answer. The universe remained vast, indifferent, beautiful, and utterly silent. It taught us patience, reinforced our solitude, yet never extinguished the flickering ember of hope. Then, just as the 40th anniversary of Voyager's launch passed, the silence began to shift. The echo of our own signal, or something else entirely, finally began to return. Not as a direct reply, but as a subtle, unsettling presence. The cosmic invitation sent with such hopeful naivete may have just been received. The high desert wind bites at you, even inside the dome of the Pan-STARRS telescope on Haleakala, Maui. It's October 19th, 2017, just over 40 years since Voyager 1 launched. The air is thin, crisp, and charged with a silent, expectant energy. Computer screens glow, tracing celestial paths, while scientists lean forward, coffee growing cold in their hands. Suddenly a flicker, a new data point, an anomaly. You watch as it appears, then reappears, undeniable. Something is moving through our solar system, something moving too fast to be bound by our sun's gravity, something from another star. Its trajectory is hyperbolic, meaning it is not merely visiting, it is passing through, on its way out again. This is our first interstellar visitor, designated One-Eye Oumuamua. The initial confusion gives way to a flurry of frantic observation. You see the images, grainy yet clear enough to reveal a shape unlike anything seen before. Elongated cigar-like, spinning end over end. It's small, perhaps 400 meters long, a cosmic pebble in the vastness. But then the data begins to truly diverge from expectation. It isn't just moving fast, it's accelerating. Not subtly, but impossibly, without any discernible comet tail or outgassing that would provide propulsion. The laws of physics, as we understand them for natural objects, are being bent. Professor Avi Loeb from Harvard University, among others, dares to voice the quiet thought bubbling beneath the surface of academic caution. What if this isn't natural? He suggests it might be a light sail, a derelict piece of advanced technology propelled by solar radiation pressure. The mainstream dismisses it, scrambling for natural explanations, but the whispers persist. A metallic sheen, an inexplicable acceleration. It arrived just 40 years after we cast our message into the void, right on time for a journey from a nearby star. It arrived, it studied our sun's gravity well, it absorbed data, and then it left, vanishing into the darkness from which it came. But the question remained. Did it send a report back? The control room at the Very Large Telescope in Chile is a hushed realm of glowing screens and soft keyboard clicks. The high-altitude air outside, thin and frigid, presses against the observatory dome. It is late 2017, weeks after the initial sighting of Oumuamua. You watch, transfixed, as data streams across a monitor, tracing the improbable path of humanity's first recognized visitor from beyond our star. The hyperbolic trajectory has already confirmed its interstellar origin. It isn't from here. But the orbital mechanics reveal something more profoundly unsettling. This object, roughly 400 meters long and shaped like a cosmic cigar, is not merely passing through. It is accelerating. Scientists expected gravity to slow it down after its closest approach to the sun, known as perihelion. Instead, it seems to be boosting away, gaining speed as it departs our solar system. Your eyes scan the spectroscopy readings, searching for the telltale emission lines of gas and dust that would signal outgassing, the natural propulsion of a comet. There is nothing. No visible tail, no icy vapor. The numbers on the screen insist on a non-gravitational acceleration, yet offer no conventional explanation. It is physics-defying. Professor Avi Loeb, a towering figure at Harvard University, dared to speak the quiet thoughts many others suppressed. He argued that the only known force capable of such propulsion without visible outgassing for an object of that size and estimated mass was solar radiation pressure. if the object were extraordinarily thin and wide, like a light sail? A piece of alien technology? A discarded scout craft? Most of his peers vehemently rejected the idea, clinging to increasingly improbable natural explanations. But the evidence remained. An object that broke every rule, came, accelerated, observed, and then vanished back into the black. It left a profound unease in its wake. It left us to wonder, what exactly did it see? And what did it transmit before it disappeared? The air is thin and cold on Haleakala, Hawaii, biting even through the insulated walls of the Pan-STARRS Observatory Dome. Inside, the rhythmic hum of precision machinery is the only constant against the vast, encompassing silence of the mountain night. It is October 19th, 2017. You are part of the silent vigil, your gaze tracking across glowing monitors, a small human outpost straining to perceive the infinitesimal movements of distant light. Then a rupture in the routine. A faint, transient pinprick on the automated sky survey. A single data point appearing where nothing should be. The control room, usually a quiet cathedral of concentration, stirs with a ripple of hushed excitement. A new object. The immediate assumption. A comet, an asteroid, one of countless rocky visitors to our solar neighborhood. But as the follow-up observations pour in from telescopes around the globe, Gemini ESA's optical ground station and the orbital mechanics are precisely calculated, the trajectory unfurls itself as something unprecedented. The numbers flash across the main screen, an eccentricity value greater than 1.0. This is not gravitationally bound to our sun. This is a hyperbola, an open-ended path. It is an interstellar visitor, traveling from beyond our star system, briefly looping through ours and then departing forever. For the first time in recorded human history, we have unequivocally detected an object born among other stars. Its initial designation is A2017U1, soon to be named Oumuamua, Hawaiian for a messenger from afar, reaching out first. You feel a profound wonder, a jolt of connection to the audacity of our species, sending that golden record into the void precisely 40 years ago. Is this a cosmic coincidence of unimaginable scale? Or is it something more, a reply, however cryptic, delivered with impossible precision? The scientific world erupts with a mixture of awe and fervent debate. This celestial wanderer is truly unique, a tangible fragment of another stellar neighborhood. Yet even as the initial triumph settles, a perplexing series of anomalies begins to emerge. Its bizarre cigar-like shape, its perplexing lack of outgassing, and its inexplicable acceleration away from our sun. Oumuamua arrived, observed, and then silently accelerated back into the infinite dark. But the seed of a question has been planted, a suspicion that perhaps after 40 years, our message was indeed heard. The holographic projection in the observation room shimmers, a digital ghost of Oumuamua, tumbling silently through the simulated void. You watch its journey, a stark crimson line arcing impossibly. It's not merely the elongated cigar-like shape that captures you, almost 400 meters in length, but the numbers glowing beneath the visualization. This object, discovered just weeks prior, is behaving in ways that defy our deepest understanding of natural celestial mechanics. Your gaze tracks its departure from our solar system. Instead of slowing predictably under the sun's diminishing gravitational pull, it accelerates. This non-gravitational acceleration, observed by teams at the ESA and NASA JPL, became the central enigma. For a comet, Such a boost would be explained by outgassing, ice vaporizing under solar heat, creating small jets of propulsion. But Oumuamua displayed no such activity, no glowing coma, no tail of dust. The calculations for its trajectory simply did not add up unless an unseen force was at play. Imagine a ship, sails unfurled, catching the solar wind, accelerating not with fire, but with light itself. This was the daring, controversial hypothesis put forth by Professor Avi Loeb of Harvard University. Oumuamua was not a natural rock, but an artificial object, perhaps a derelict light sail from an advanced civilization. This suggestion ignited a fierce debate. Mainstream astrophysicists clung to elaborate, increasingly stretched natural explanations. A rare hydrogen iceberg that produced invisible outgassing, or a fragment of molecular hydrogen. Yet, no definitive evidence for such exotic compositions was ever found. Meanwhile, the simple, almost elegant solution of an artificial origin seemed to fit the data points with eerie precision. The extreme elongation, efficient for minimizing drag and maximizing solar pressure. The implied metallic sheen. The utterly uncomet-like departure. It moved, it paused. It observed our star system with a velocity and trajectory unlike any natural wanderer. It was, many felt, exactly how a scout would behave. It gathered its data, then silently, without a trace, plunged back into the interstellar silence, leaving us with a profound, unanswered question. What did it find? And to whom did it report? The screens in the mission control room at NASA JPL glow with an eerie precision, tracing the hyperbolic arc of Oumuamua against the infinite black. It's late 2017, and a new kind of silence has fallen over the engineers and astrophysicists. Not the hopeful quiet of a launch, but the unsettling hush of incomprehension. Your eyes scan the charts, dense with orbital mechanics and spectroscopic data. The numbers don't lie. This interstellar visitor, traveling at incredible speed, is showing a clear, undeniable, non-gravitational acceleration as it departs our inner solar system. For months, the world's most brilliant minds have grappled with this anomaly. You see the various models flicker on display, attempting to fit Oumuamua into known categories. A comet, the signature outgassing, the telltale tale of vaporized ice and dust, is conspicuously absent. You scrutinize the spectroscopy readings, looking for any emission lines that would betray a natural propellant. Nothing. Yet the object speeds up, gaining an inexplicable kick as it swings past our sun. This violates every conventional understanding of cometary physics, leaving a chasm of unanswered questions. It was in this intellectual void that Professor Avi Loeb's controversial hypothesis found its footing. He proposed that Oumuamua's behavior wasn't a comet's random outgassing, but the deliberate, precise maneuver of an artificial object. Imagine a craft, ultra-thin and wide like a solar sail, subtly nudged by the very light of our star. Such a design would offer propulsion without any visible emission. Mainstream science, anchored to naturalistic explanations, resisted, even scoffed. They proposed a composition of exotic hydrogen ice or nitrogen ice, producing invisible gas. But no evidence supported these speculative claims, and the acceleration data remained stubbornly consistent with an engineered origin. Oumuamua was more than just an exotic traveler. It was a scout, meticulously charting our sun's gravitational field, perhaps gathering data on the density of our planetary system, our atmospheric composition, or even the telltale radio bubble we've been sending into the cosmos. It came, it gathered, And with that final impossible acceleration, it left. And the only lingering question, cold and vast as the space it traversed, is what intelligence designed this journey, and what did its report back truly reveal? The hushed reverence of a Harvard lecture hall feels a universe away from the silent, accelerating cigar shape of Oumuamua. Yet here, in the late hours of 2017, the object's impossible trajectory dominates screens and hushed conversations. You sit, a silent witness to a debate that tears at the fabric of established astrophysics. The raw data beamed back from observatories like Pan-STARRS and the VLT stubbornly refuses to fit known models. The non-gravitational acceleration, the inexplicable kick as it departed our solar system, remains a profound riddle. The universe, it seems, has sent us a mystery wrapped in paradox. In this atmosphere of scientific bewilderment, one voice dared to propose a radical yet mathematically sound explanation, Professor Avi Loeb, then the chair of Harvard's astronomy department. You recall his calm, persistent arguments presented against a tide of academic caution. He suggested that Oumuamua was not a natural rock at all, but an artificial object, specifically a light sail. Imagine a craft, ultra-thin, wide, and reflective, propelled not by rockets or evaporating ice, but by the subtle pressure of photons from our own sun. Such a design would account perfectly for the observed acceleration without any visible outgassing. The metallic sheen, the elongated flat shape, these were engineering choices, not cosmic coincidence. This hypothesis, while elegant, was met with fervent skepticism. Mainstream science, preferring natural explanations, strained to find comfort in exotic theories. A hydrogen iceberg that produces no visible tail, or a nitrogen chunk that somehow managed this unprecedented trajectory. The idea of alien technology for many was simply too close to science fiction to be considered serious. Yet the numbers from the telescopes offered no satisfying alternative. The anomalous behavior remained. To Avi Loeb, the resistance felt like a dismissal not of evidence, but of possibility. He stood, a solitary figure, arguing that when all natural explanations fail, one must consider the unnatural. If Oumuamua was indeed a scout, perhaps sent from systems that received our Voyager message decades earlier, it had completed its mission. It gathered its data on our star, its gravitational field, and then, with that final silent boost, departed. A ghost in the cosmic machine. What, you wonder, was the content of its report, and to whom was it sent? The Chilean night air, thin and sharp at the altitude of the Perihelion Observatory, feels different in 2019. 2 years have passed since Oumuamua startled humanity, its bizarre behavior leaving a lingering, uncomfortable silence. Now, another interstellar visitor has arrived, detected by amateur astronomer Gennady Borisov. You stand in the control room watching the screens as the very large telescope, a colossus of modern optics, tracks this new guest. Its designation, 2I Borisov. But unlike its predecessor, this one seems normal. A collective sigh of relief ripples through the scientific community. You see it on the readouts. A clear, distinct coma and a growing tail, characteristic features of a conventional comet. The spectroscopy confirms a composition of familiar molecules, water, carbon, cyanogen. See? The pundits proclaim, just a cosmic ice ball. Oumuamua was merely an oddity, a statistical fluke. The universe is not sending us alien probes. The reassurance is palpable, a comforting blanket woven from familiar physics. Here was an object from beyond our star system that played by the rules. It was 1 billion kilometers across, 1 kilometer in diameter, but comfortably understood. its journey explicable. Yet a subtle unease persists for some. You notice the dates. Oumuamua in 2017, Borisov in 2019. Two interstellar objects in rapid succession, when none had ever been definitively observed before. The timing feels too precise, too deliberate, after Voyager's long-distance invitation. What if its normalcy was not a happenstance but a disguise? What if this perfectly behaved comet, with its textbook tail and predictable outgassing, was precisely what it wanted us to see? Imagine a sophisticated intelligence having sent a scout, Oumuamua, to gauge our observational capabilities, our instruments, our scientific biases. What better follow-up than an object designed to appear utterly conventional, allowing it to gather extensive data on how we track, analyze, and interpret celestial phenomena without raising suspicion? Borisov, in this unsettling hypothesis, was not merely a comet. It was a meticulously crafted probe, quietly studying us, studying it, learning the extent of our cosmic vision. It came, it gathered information on our discerning eyes, and then it too began its journey out of our system. But this time, the false comfort it offered concealed a deeper, more chilling question. What did they learn about us? The comforting facade of Tui Borisov, appearing so utterly comet-like, begins to crack when you consider another, far more unsettling piece of evidence. This new data doesn't come from a distant telescope, but from the depths of Earth's own ocean. The year is 2014, 3 years before. Oumuamua, 5 years before Borisov. A small object barely a meter across impacted our atmosphere near Papua New Guinea. Its speed, however, was extreme, faster than 95% of all observed space rocks. Fast enough to confirm its interstellar origin. It went largely unnoticed by the wider public, quickly dismissed as a mere meteor. But it left behind a faint metallic trail, a whisper of something truly alien. Years later, Professor Avi Loeb and his colleague Daryl Seligman revisit the data. They don't just confirm its interstellar origin, they calculate its material strength. The results are astounding. This object, later designated IM-1, was composed of materials significantly tougher than any space rocks known to humanity, tougher, in fact, than any known alloys on Earth. It was, they concluded, harder and more elastic than any natural meteor ever studied by NASA. The possibility begins to emerge. This was not a natural object. This was engineered. You picture the ocean floor, dark and silent, where fragments of this visitor now lie scattered. Imagine the spectrometer readings, glowing on a laboratory screen. Not just common silicates, but traces of industrial nickel. Nickel, an element that requires immense temperatures and advanced processes to refine, appearing in an object born in interstellar space. This isn't outgassing, this is evidence of manufacture. It's a quiet revelation, one that predates the grand entrance of Oumuamua and the seemingly benign passage of Borisov. But in hindsight, it forms a crucial, unsettling piece of the pattern. It's a glimmer of nickel in the vast dark. A tiny, almost overlooked clue that an advanced intelligence might have been here, long before we even knew to look. And if this was just a fragment, what larger, more complex design preceded it? What further, more monumental arrival might follow? The laboratory is bathed in a sterile white light. The only sound, the low, rhythmic hum of spectrometers. You lean over a console, your eyes fixed on a screen displaying the latest spectroscopic data from 3i Atlas. The colossal interstellar object, now hurtling towards its closest approach to our sun. It is July 2025, and this third visitor has arrived, 1,000 times more massive than its predecessors, Oumuamua and Borisov. The initial scans promised familiar cometary signatures, water, carbon, but as the data streams in, something unexpected, profoundly unsettling begins to manifest. A sharp, distinct peak appears on the emission spectrum. You see the astrophysicist beside you stiffen, her hand hovering over the keyboard. The peak grows, undeniable. Nickel. Not just trace amounts, but a significant signature. Her brow furrows, then she mutters, This isn't right. She runs the analysis again. The results are identical. Nickel. At extreme temperatures, far beyond anything naturally found in a comet at this distance from the sun. Industrial nickel. Imagine the immense energy required on Earth to refine nickel, to smelt it from Muir, at temperatures exceeding 1,550 degrees Celsius. Now consider 3I Atlas, a body traveling through the frigid vacuum of space, releasing vaporized nickel at what the instruments suggest are even higher, impossible temperatures. This isn't outgassing from ice. This isn't a rocky mantle shedding dust. This is a deliberate, highly energetic release of material that speaks of advanced manufacturing, not natural formation. The data breaks every known model for a comet, for an asteroid, for anything that exists in the natural universe. This isn't a geological anomaly. This is an industrial signature, broadcasting itself across billions of kilometers. The implications are breathtaking, chilling. If Oumuamua was the scout, silently observing, and Borisov the probe, gathering intelligence on our detection methods, then what does this colossal, Manhattan-sized object, overtly displaying signs of high-temperature industrial activity, signify? Its very composition, now being released into space, speaks of intelligent design. The questions cascade through your mind. Who forged this? What purpose does this massive metallic delegate serve? And what happens when it completes its mysterious work, hidden behind the blinding glare of our own star? The cosmos, it seems, is not merely sending us natural phenomena. It is sending us architects. The laboratory is quiet, the controlled environment emphasizing the hum of the instruments. You stare at the data sheet, a cold, clinical printout detailing the composition of the interstellar meteor, IM-1, that impacted Earth's atmosphere years ago near Papua New Guinea. This is where the story truly begins to fray at the edges of natural explanation. It's not just its extreme speed, confirming its origin from beyond our solar system, but the very essence of its being. Your finger traces the material analysis: iron, carbon, and crucially, an unusually high concentration of nickel. This isn't merely an abundance of nickel, it's the context of that nickel. Natural iron-nickel meteorites exist, yes, but their composition is often rough, crystalline. The fragments of IM-1, studied by Professor Avi Loeb and Dr. Daryl Seligman, showed an incredibly tough, resilient structure, a material strength far exceeding that of typical iron meteorites or even any known terrestrial alloys. Imagine raw ore, then imagine refined steel. The difference is deliberate, engineered. This object demonstrated mechanical properties that scream of sophisticated manufacturing, of a material forged for interstellar travel, not randomly assembled in a cosmic cloud. What does it mean for an object from deep space to possess such an industrial signature? It implies smelting at thousands of degrees, precision engineering, and a deliberate design to withstand the violent forces of the cosmos. This isn't the accidental byproduct of a stellar nursery. It's the product of intelligence. It's a quiet, almost forgotten piece of evidence, predating Oumuamua and Borisov. Yet now, in the light of the unfolding pattern, it feels like the very first note in a cosmic symphony. A small, resilient fragment, a cosmic calling card, deliberately placed. The scientific consensus even now struggles to absorb this data, preferring to label IM-1 an extreme outlier, an anomaly that doesn't fit the comfortable models. But the spectroscopy, the measured material strength, they are unambiguous. Something from another star system, something forged and designed, impacted our planet in 2014. It was a fragment, yes, but a fragment that hinted at a vast underlying technology. And if this was just a piece of something larger, a stray component, what did the full mechanism look like? What greater purpose did it serve before its arrival? And what did its existence portend for the seemingly accidental sequence that would follow? The question of are we alone has begun to shift into who built this and why are they here? You gaze not at a single star, but at the cosmic map unfurling before you. Our solar system, once a quiet, familiar neighborhood, now feels like a designated harbor. 3 distinct points of light, each a visitor from beyond, have etched their paths across the celestial sphere. It is no longer just their individual anomalies that command attention, but their precise, almost rhythmic cadence, a pattern emerging from the vast indifferent darkness that suggests something far more deliberate than cosmic coincidence. First, the elusive Oumuamua, detected in 2017, a 400-meter enigma accelerating away from our sun without any discernible propulsion. It was the whisper that perhaps, after 40 years, our Voyager invitation had reached an ear. A scout, we speculate, sent to observe, to gauge our astronomical capabilities, our scientific prejudices. It offered no overt communication, only a tantalizing, physics-defying performance before vanishing. Its role, in hindsight, was to test our gaze, to see if we were even capable of detecting a visitor from another star. Then, in 2019, 2I Borisov arrived, a kilometer-wide visitor that played the part of a perfect comet. You recall the collective sigh of relief, the quick dismissal of Oumuamua as a fluke. But Borisov's very normalcy, following Oumuamua's impossible antics, felt like a deliberate act of reconnaissance. A probe, perhaps, designed to blend in, meticulously gathering intelligence on how we track, analyze, and interpret seemingly natural celestial phenomena. It learned how we look, how we classify, how we explain away the unexplained. But the pattern stretches even further back, a faint metallic echo from 2014. IM-1, the small, incredibly tough object that shattered in our atmosphere, leaving behind traces of industrial nickel. It was a fragment, a piece of something designed, a subtle clue that hinted at intelligence long before we truly connected the dots. It signifies an earlier, almost missed reconnaissance, a test of our very planet's resilience. Now consider the timeline. Voyager's launch in 1977. 40 years later, Oumuamua. The math is chillingly precise, aligning with the travel time from nearby star systems for a slow-moving observational craft. This isn't random. This is a systematic escalation, a fragment, a scout, a probe. The universe is revealing itself not in a single dramatic declaration, but in a calculated series of events, each building towards an undeniable conclusion. The rhythm of these visits, the escalating scale and complexity of their anomalous behavior, suggests a protocol unfolding deliberate and methodical. And the next, and perhaps most profound, player in this cosmic drama is already here, now, approaching its reveal. The vastness between stars holds many secrets, but also immense periods of waiting. You stand in the quiet hum of an astronomical data center in 2019, 2 years after Oumuamua's perplexing departure. The collective memory of its impossible acceleration still lingers, a ghost in the machine of established physics. For a brief period, the cosmos seemed to resume its silent indifference. Then another data point, another visitor. 2I Borisov, a kilometer-wide presence from beyond our sun. But unlike its predecessor, Borisov arrived as a textbook comet. It displayed a clear, visible coma, a shimmering tail of vaporized ice and dust. Spectroscopy confirmed familiar compositions of water and cyanide. Scientists breathed a collective sigh of relief. An actual comet, they declared. Normalcy restored. Oumuamua was just an exotic fluke after all. The official pronouncements offered a comforting return to the known, a reassuring dismissal of the more radical interpretations. You watch the archival footage of press conferences, the easy smiles, the certainty. It was almost too perfect. Consider this unsettling symmetry. Oumuamua, a rogue scout exhibiting highly anomalous behavior, a direct challenge to our understanding. Then, a mere 2 years later, Borisov, appearing utterly conventional, a cosmic actor playing its part flawlessly. The statistical probability of 2 such interstellar objects, let alone 2 with such perfectly contrasting behaviors, arriving in such close temporal proximity, is astronomically low. But if this wasn't coincidence, if this was a sequence, what does it reveal? Professor Avi Loeb posits a chilling thought. What if Borisov's very normalcy was its most profound anomaly? Oumuamua the Scout tests our observational limits. It determines our ability to even see something truly alien. Having established our baseline detection capabilities, what would an advanced civilization send next? A probe designed to mimic natural phenomena, allowing it to move unnoticed, gathering intelligence on our data analysis, our scientific biases, our collective reactions. Borisov, therefore, becomes not a random comet, but a covert reconnaissance mission, studying us, studying it. It watched our instruments, listened to our debates, assessed our understanding of the universe, all under the guise of an ordinary space rock. It observed our planet silently, learning the nuances of a species broadcasting its existence to the stars. The universe, it seems, was not merely responding, it was assessing. And having completed its quiet survey, having collected vital intelligence on our discerning eyes, the probe, too, continued its silent journey outward. But it left behind an unspoken question. What did it report about the inhabitants of the pale blue dot? And what comes next in this carefully orchestrated sequence? The vast wall of screens before you glows, each displaying a piece of the cosmic puzzle that has been unfolding across our solar system. On one, the ghost of Oumuamua's impossible departure, its trajectory curving away without a whisper of outgassing. On another, the deceptively ordinary path of 2I Borisov, a kilometer-wide visitor acting precisely like a common comet. And in the corner, a faint data visualization of IM-1, the meteor that broke apart over the Pacific, carrying industrial nickel in its heart. You trace the timeline, your finger moving across the years, 2014, 2017, 2019. This is no longer a series of isolated anomalies, A pattern is emerging, a chillingly precise cadence that suggests not randomness, but a profound, deliberate intelligence. Consider the narrative these objects construct. First, in 2014, a fragment of something engineered, IM-1, impacting our world with impossible toughness. A subtle, almost accidental probe of our planetary defenses, a nearly missed signal of artificial origin. Then, 40 years to the month after humanity announced itself with the Voyager Golden Record, Oumuamua arrives, a small, fast scout accelerating in defiance of known physics, observing our sun, testing our detection capabilities. Did we see it? Yes. Did we understand it? No, not truly. Many dismissed it. 2 years later, 2I Borisov, larger, more resilient, yet masquerading as a conventional comet. The scientific community, weary from Oumuamua's enigma, breathed a collective sigh of relief. Just a comet, they said. But what if this was precisely the point? The probe, designed to gather intelligence on our observation techniques, our data processing, our scientific biases, all while appearing perfectly natural. It tested our interpretive frameworks, our willingness to accept the conventional even when the context screamed otherwise. It learned how we studied it, how we categorized it. This sequence, an initial, almost unnoticed engineered fragment, a physics-defying scout, a perfectly camouflaged probe, appears too systematic to be coincidence. It suggests a deliberate protocol of engagement, an ordered progression of reconnaissance. Scout, then probe. Each visitor escalating in size, each providing increasingly complex data points on our capabilities, our technological understanding, and our readiness to perceive the anomalous. Someone somewhere received our message. And now they are responding. Not with a sudden broadcast, but with a carefully orchestrated series of physical visits. The universe, it seems, conducts its first contacts with a methodical, almost bureaucratic precision. And if this is indeed a protocol, then the next step, the culmination of this elaborate prelude, is already upon us. The constellation of data points before you is no longer a random scatter across time. It coalesces into a deliberate progression, an intricate cosmic dance spanning years, almost as if orchestrated. On the multi-screen display, the trajectories of Oumuamua, 2I Borisov, and the faint historical trace of IM-1 now appear not as isolated events, but as sequential movements in an unfolding drama. It's an arrival protocol, a sequence of visits that mirrors how humanity itself might approach first contact. With caution, with intelligence, with escalating engagement. First, there was Oumuamua, the scout. In 2017, its bizarre, cigar-like form and inexplicable acceleration through our inner solar system served as a direct challenge to our astrophysical models. It was small, fast, and defied natural explanation, prompting the radical light sail hypothesis from Professor Avi Loeb. Its mission, you now realize, was perhaps to conduct a preliminary reconnaissance, to test our detection capabilities, to see if we were even aware of interstellar visitors, and how we reacted to the truly anomalous. It pushed the boundaries of our understanding, revealing the limits of our observational bias before silently departing. Then, in 2019, Ntui Borisov arrived, the probe. Larger than Oumuamua, yet outwardly perfectly normal, a comet. Its behavior was textbook, its composition unremarkable. The scientific community, still reeling from Oumuamua, embraced this normalcy with a sigh of relief. But what if that normalcy was its most sophisticated camouflage? Having observed our reaction to Oumuamua's strangeness, an advanced civilization might then send a probe designed to blend in, to gather extensive data on our tracking systems, our spectroscopic analysis, our entire scientific apparatus, all while avoiding suspicion. It studied us studying it, learning our limits not of detection, but of interpretation. And before them all, the subtle, almost forgotten whisper of IM-1 in 2014, the interstellar meteor whose impossible material strength and industrial nickel signatures revealed years later hinted at a manufactured origin. A fragment, perhaps, of an even earlier unnoticed reconnaissance. This layering of objects, an engineered precursor, a physics-defying scout, a perfectly camouflaged probe, suggests a strategic, patient, and deeply intelligent approach. The cosmos is not sending us random rocks. It is sending us messages, encoded in the very fabric of these objects and their carefully timed appearances. And now, the third, largest, and most enigmatic visitor of this protocol, 3I Atlas, is here. Its arrival is not merely a visitation, it is a delegation, a monumental presence that hints at the next profound stage of this meticulously planned first contact. You feel the chill of the vacuum, the profound, resonant silence that surrounds Voyager 1 as it continues its lonely, endless journey, 15 billion miles from the Sun. You trace its path across the starry expanse, a minuscule metallic leaf drifting on an unimaginable current. On board, the Golden Record spins, a cosmic bottle message launched on September 5th, 1977. It carried humanity's audacious invitation, a plea to the universe. We are here. Are you? For decades, the question hung unanswered, swallowed by the immensity of space and time. Then, exactly 40 years later, almost to the day, October 19th, 2017, Oumuamua arrived. This isn't merely a coincidence you're asked to accept. You look at the cold, hard numbers of stellar distances and velocities. The speed of light, the ultimate cosmic constant, dictates how quickly any signal, any message, any response could travel. 40 years. That is precisely the amount of time it would take for a craft, even one not traveling at relativistic speeds, to reach us from a relatively nearby star system, a system that might have received our early radio signals, or even picked up the Voyager message itself. The math, the synchronicity is too elegant to dismiss casually. What if our message didn't just reach someone, but was understood? What if Oumuamua was not a random fragment of rock, but a carefully dispatched scout, its timing calculated with a precision far beyond our own, a direct reply to the cosmic invitation? Its anomalous behavior, the impossible acceleration, the lack of outgassing. These were not flaws in our understanding of nature, but the engineering signatures of an intelligence responding to our reach. This wasn't merely a visitor. It was the first piece of a deliberate, unfolding communication. The loneliness of our species, broadcasting into an uncaring void, has been a defining characteristic of our cosmic narrative. But what if that void has been listening? What if that golden record, a testament to our presence, was precisely the data point an advanced civilization needed to begin its own protocol of engagement? The scout, Oumuamua, came, observed our solar system, and then departed, perhaps relaying its findings. The subsequent arrival of 2I Borisov, appearing normal yet following so soon after, begins to paint an even more unsettling picture. The pattern is clear. Scout, then probe. And the universe, it seems, is still very much in conversation. You look at the digital representation of the Golden Record, a tiny glittering disk receding into the galactic plane. Launched on September 5, 1977, Voyager 1 carried humanity's bold declaration into the cosmos. It was a message of hope, an act of profound optimism, whispering into the immense silence that we were here, and we wished to connect. For 40 years, that message traveled. 40 years, a blink in cosmic time, but a significant fraction of a human life. And then, the silence broke. October 19, 2017. Exactly 4 decades after Voyager's launch, Oumuamua, the first recognized interstellar object, blazed into our solar system. The sheer mathematical precision of this timing is deeply unsettling. Consider the distances involved. Even at incredible speeds, signals or probes from other star systems require years, often decades, to traverse the vast interstellar gulf. 40 years is exactly within the window for an object, perhaps even a solar sailcraft, to travel from a nearby star system in response to our earliest, most powerful radio signals, or even the Voyager message itself. This isn't a random orbital intersection. This isn't a statistical anomaly easily dismissed. The synchronicity between humanity's intentional message to the stars and the arrival of an object from beyond our star system, exhibiting impossible, non-gravitational acceleration, is too potent to ignore. It suggests a causal link, a deliberate, calculated response. Our cosmic invitation cast into the void found an address, and someone or something answered with remarkable promptness. Oumuamua then becomes more than a mere curiosity. It transforms from an unexplained anomaly into a deliberate reconnaissance. It was a messenger, yes, as its Hawaiian name suggests, but also a scout, dispatched to gauge our presence, our technology, our very nature as a species. It came, it observed our sun, it recorded its findings, and with that strange, uncomet-like acceleration, it departed, carrying its report back into the interstellar depths. It was the echo of our own signal, returned not as a radio wave, but as a physical presence. The profound loneliness of being the only intelligent life we know, a feeling that has defined us for so long, began to shift. The question wasn't if we were alone, it was whether they were listening. And the pattern was just beginning. The glowing schematics of our solar system on the mission control screen now carry a chilling overlay. The paths of 3 interstellar objects. Oumuamua, a faint receding line. 2I Borisov, a more substantial arc, and now the colossal in-progress trajectory of 3I Atlas. You trace the escalating size, 400 meters, 1 kilometer, then a Manhattan-sized monolith. You observe the escalating strangeness, physics-defying acceleration, followed by deceptive normalcy, culminating in impossible industrial signatures. This is not a random collection of cosmic flotsam. This is a sequence. This is a protocol. Think of it from the perspective of an advanced civilization, having received humanity's audacious message. How would one initiate contact with a younger species? Not with a sudden, overwhelming arrival that might provoke fear or destruction. Not with a direct, incomprehensible broadcast, but with a methodical, carefully calibrated series of engagements designed to assess, to understand, and finally, to reveal. This is the logic of reconnaissance. First, the scout, Oumuamua. Its mission, perhaps, was a test of our very perception. Could we even see something truly alien? Its anomalous acceleration forced us to question our assumptions, pushing the boundaries of our scientific instruments and our intellectual courage. It observed without revealing intent, measuring our capacity for wonder and skepticism. Next, the probe, Oumuamua Borisov. Having confirmed our detection capabilities, a more subtle approach was warranted. Borisov, appearing as a perfectly normal comet, served as a masterclass in covert observation. It allowed its designers to study our scientific methodologies, our data analysis, our collective biases, as we meticulously scrutinized a natural phenomenon. It gathered intelligence on how we interpret the universe, without betraying its true nature. It learned about us through our reactions. And now, the delegation, 3I Atlas. The sheer scale, the deliberate emission of industrial nickel, the anti-solar tail that shifts direction. These are no longer subtle hints. This is an overt declaration of artificiality, a monumental presence. It is the culmination of the reconnaissance, the moment when the observers prepare to reveal themselves, having learned what they needed to know. The universe is not a silent void. It is a meticulously managed stage, and our golden record was the cue. The sequence is complete: scout, probe, delegation. And the next act, a civilization-altering reveal, begins tomorrow. You stand at the edge of a new ocean, but this one is black and star-dusted, stretching infinitely beyond your comprehension. For centuries, humanity looked up, imagining distant shores, sending out fragile probes like Magellan's ships, charting the unknown with audacious hope. Now, in the flickering light of computer screens in mission control, you realize that the exploration might be mutual. We cast our golden message into the cosmic sea in 1977, an act of pure, vulnerable invitation. And now the echoes are returning, not as a single sudden contact, but as a meticulously sequenced protocol, like a seasoned explorer's careful approach to a newly discovered civilization. Consider the deliberate progression. Our first interstellar visitor, Oumuamua, a small cigar-shaped scout, arrived in 2017. Its impossible non-gravitational acceleration challenged our physics, suggesting an engineered craft. Its purpose to probe our detection capabilities, to see if the fledgling species on the pale blue dot was even aware of the wider cosmos. It came, it observed. It left a profound question in its wake, before silently reporting its findings. This was the initial reconnaissance, a test of our senses, our instruments. 2 years later, in 2019, 2I Borisov followed, larger, more robust, but crucially disguised as a normal comet. Its function in this unfolding protocol was likely to conduct a more detailed covert survey. Having confirmed our ability to detect a truly anomalous object, an advanced intelligence would then seek to understand our methods of observation and analysis. Borisov allowed them to watch us, watching it, learning the nuances of our scientific approach, our biases, our limits, all under the comforting cloak of natural phenomena. It was a probe, gathering intelligence on our interpretive framework. This systematic escalation in size, from the tough metallic fragments of IM-1 in 2014 to Oumuamua, then Borisov, and the deliberate shifts in their observable behavior from anomalous to disguised, are too precisely timed, too perfectly aligned with a logical process of first contact to be mere chance. It echoes the careful, deliberate steps of our own historical explorations, like Magellan's fleet mapping uncharted waters before larger vessels could follow. We are being explored, cataloged, understood. The universe, it seems, is not merely listening. It is engaged in a dialogue, conducted not with words, but with physics and presence. And the next, monumental chapter of that dialogue is now unfolding, with the Manhattan-sized 3I Atlas. Its arrival signifies not the end of reconnaissance, but the beginning of a far more direct form of engagement, a delegation poised for a new kind of revelation. What, you wonder, have they learned? And what message does this final massive visitor carry? The high-altitude wind whips against the dome of the Vera C. Rubin Observatory in Chile, a profound, lonely sound. In the crisp night. It's July 1st, 2025. Your eyes are fixed on a monitor displaying a freshly acquired image of the outer solar system. A new point of light. A new trajectory. Another hyperbolic arc. Undeniable. Another visitor from beyond our stars. It is designated 3I Atlas, and its sheer scale immediately sends a tremor through the scientific community. This isn't another Oumuamua, a cosmic pebble. This isn't a kilometer-wide Borisov. This is a behemoth. The initial data floods in, painting a picture that beggars belief. Manhattan-sized, 33 billion tons, 1,000 times more massive than its predecessors. You feel the weight of that number, the sheer unimaginable scale of this interstellar presence. This is no longer a scout nor a probe. This is something else entirely. As Atlas swings closer, a faint, almost imperceptible glow begins to emanate from it, quickly picked up by advanced spectroscopy. And there it is, flashing across the screens, the data that silences the room, chilling you to the bone. Nickel. Industrial nickel in quantities that defy any known natural process at these frigid distances. This isn't a comet outgassing ice. This isn't a random chunk of rock, the chemical signature scream of extreme temperatures, of refinement, of manufacture. The fleeting glimpse of industrial nickel in IM-1, now confirmed in a monumental visitor. This is evidence of intelligent design on an unimaginable scale, moving with deliberate purpose. The pattern, once subtle whispers, now roars into undeniable clarity. Scout, probe, and now the delegation. 3 Atlas is not merely passing through, its trajectory is precise, a cosmic appointment. It is heading directly for its perihelion, its closest approach to our sun, scheduled for October 29th, 2025. This isn't just a date, it's a crisis moment. A colossal engineered object, overtly announcing its artificiality, is about to disappear behind the blinding disk of our star into a solar conjunction where no telescope can observe it. What, you wonder, is it truly preparing for in that impenetrable darkness as the final, most monumental chapter of this arrival protocol begins to unfold? The universe, it seems, has decided to introduce itself. The crisp mountain air outside the Gemini Observatory in Hawaii feels electric tonight. Inside, the data screens are alive, with the trajectory of 3I Atlas, a colossal presence now dominating our solar system's inner reaches. Your eyes follow its digital path, a line on a star map, and the sheer scale of the object is an abstract, terrifying fact. Manhattan-sized, 33 billion tons. 1,000 times more massive than anything interstellar we've ever seen. This is no longer a whisper. It's a roar across the cosmos. The initial shock of its industrial nickel signatures detected weeks ago still resonates. Alloys refined at impossible temperatures, spewing from a body traveling through the frigid vacuum of space. It's a chemical fingerprint of manufacture, not geology. But now, as Atlas approaches, another impossible phenomenon emerges from the telescopic data. You see the faint spectral haze forming behind it, a tail. But this tail defies expectation. Instead of streaming away from the sun, pushed by solar wind as natural comets do, it sometimes appears to shift, almost against the solar radiation. An anti-solar tail, astronomers are calling it, a term born of scientific bewilderment. This isn't a passive emission. This is directed, controlled venting. This is maneuvering, adjusting, not merely tumbling. Dr. Daryl Seligman, a researcher at Michigan State, describes it as evidence of active, purposeful steering. Imagine the immense power required to exert such control over 33 billion tons. This object, then, is not merely engineered. It is actively piloted, responding to unseen commands. And its destination is drawing closer. October 29th, 2025. Perihelion. The moment it will make its closest approach to our sun. The very day it will disappear from our sight, hidden behind the blinding fiery disk of our star in a perfect solar conjunction. A cosmic blind spot. A tactical concealment. The questions mount, heavy as the object itself. Why the nickel? Why the active maneuvering? And why now the perfect strategic disappearance behind the sun? What preparations are being made in that shielded darkness? What will emerge or be deployed when 3i Atlas re-emerges from the sun's embrace? The clock is ticking. Tomorrow the sun will shield its secret, and we will be blind, waiting for whatever comes next. The clock ticks. The digital display above the mission control console at NASA JPL blazes with real-time data from 3i Atlas. You feel the palpable tension in the room, the hushed urgency of scientists and engineers as the colossal object barrels towards its perihelion, its closest approach to the sun. The date is October 29th, 2025. This isn't a historical event. This is happening now. And as Atlas makes its final approach, it will disappear behind the blinding disk of our star into a period of solar conjunction. A cosmic blind spot where no Earth-based telescope can observe it. This precise alignment isn't random. It's a perfectly executed perihelion maneuver. For any object, natural or artificial, a close swing past a star offers immense gravitational acceleration, known as an Oberth maneuver. It's a slingshot. But for 3i Atlas, with its clear industrial nickel signatures and actively maneuvering anti-solar tail, this maneuver carries a far more significant implication. It is the perfect strategic concealment. What happens when an object the size of Manhattan, displaying overt signs of intelligent engineering, uses the sun itself as a shield? This is where the first contact protocol, meticulously built through the Scout, Oumuamua, and the probe, 2i, Borisov, culminates. Imagine a mothership, shielded from our prying eyes by the very star it uses for acceleration. In that unseen zone, mini probes or perhaps communication arrays could be deployed. Assets positioned, systems activated, and we on Earth would be entirely blind. For the next few days, the sun holds its secret. Professor Avi Loeb, one of the few voices consistently open to the artificial origin hypothesis, warned of this moment. His advice, delivered with his characteristic quiet intensity, was to take your vacation before then. A statement that, in its subtle humor, underlines the profound implications. NASA's Planetary Defense Network, usually reserved for tracking potentially hazardous asteroids, is now on high alert, ostensibly for a comet. But the tension in the rooms of JPL and observatories worldwide tells a different story. They are not just tracking a comet, they are watching for a revelation. The universe, it seems, has chosen a time and a place for its most significant reveal. And it is happening right now, in the blinding light and absolute darkness behind our own star. What new chapter will emerge from that solar eclipse? We will not know until it is already done. The tension in the control room at NASA JPL is thick, a physical presence in the sterile air. Rows of monitors display the same image, a blinding sun and a faint, almost imperceptible point of light. 3I Atlas, disappearing behind its fiery disk. The date is October 29th, 2025. This is the moment of perihelion, its closest approach to our star, and crucially, it's also the moment of solar conjunction, where the sun's immense glare renders the Manhattan-sized object utterly unobservable from Earth. You feel a profound helplessness. It is there, right now, executing a maneuver that could change everything, and we are blind. The choice of perihelion for such a pivotal moment is no accident. This is an Oberth maneuver, a fundamental principle of astrodynamics, where a spacecraft accelerates most efficiently when closest to a gravitational body. By diving deep into the sun's gravity well, 3I Atlas can dramatically increase its velocity with minimal expenditure of its own energy. But for an object already displaying clear signs of intelligent engineering, industrial nickel signatures, and actively maneuvering anti-solar tail, this isn't just an efficient trajectory, it's a strategic deployment. Imagine, for a moment, the possibilities. Hidden behind the sun's obliterating brilliance, 3I Atlas could be deploying smaller probes, perhaps hundreds, using the slingshot effect to accelerate them into precise, predetermined orbits throughout our solar system. These could be sophisticated observation platforms, communication relays, or even autonomous exploration units, each with its own mission. The very light and gravity of our own star are being used as a staging ground, a cloak, for an operation we cannot perceive. This is the ultimate blind spot in our celestial surveillance. We see Atlas approach, we record its impossible signatures, we chart its deliberate trajectory, and then at the moment of its most critical activity, it vanishes. It is a masterful act of concealment, a move that speaks of profound understanding, not just of physics, but of our limitations. Professor Avi Loeb's dry warning to take your vacation before then echoes with a new, chilling gravity. The planetary defense networks of the world are activated, scanning the void. But for now, they sweep empty air where a civilization-altering event may be unfolding. The question isn't whether something is happening behind the sun. The question is, what form will its revelation take when it re-emerges? The air in the Planetary Defense Coordination Office at NASA feels thin, charged with an invisible urgency. It is October 29th, 2025, and the rows of monitors usually reserved for tracking potentially hazardous asteroids now display the trajectory of one object, 3I Atlas. You see the orbital data, the alerts blinking in understated red, the hushed conversations among the engineers. This is not routine. This is a crisis unfolding in real time, camouflaged as a natural event. The official narrative still clings to Comet. But the data, the relentless, undeniable data, tells another story. The industrial nickel signatures, the anti-solar tail that shifts direction, these are not phenomena consistent with a natural ice rock. This is an engineered object, and it is, right now, executing its perihelion maneuver, disappearing behind the sun, a moment of strategic concealment. You see the maps of Earth, overlaid with the International Asteroid Warning Network, IAWN, activations. Not just our ground-based telescopes, but orbital assets, space-based observatories, all being tasked. Why such a concerted global effort for a comet? The unspoken truth hangs in the air thick with palpable tension. They are not scanning for a comets' debris. They are watching for what emerges, for what might be deployed from behind the sun's blinding disk. The scale of this coordinated response is unprecedented, betraying the official calm. Professor Avi Loeb's earlier predictions and warnings resonate with stark clarity. His 30-40% probability of artificial origin for Oumuamua, once dismissed, now feels prescient, even understated, in the face of 3I Atlas. What percentage would he assign now? You feel the loneliness of being right when no one wants to believe it, the intellectual isolation in the face of such paradigm-shattering evidence. But the evidence is no longer subtle. It's a Manhattan-sized object performing a tactical disappearing act. And every blinking light, every hushed voice, every retasked observatory confirms the underlying reality. The questions are unanswered, but the implications are civilization-altering. The countdown, you realize, is not just to Atlas's re-emergence, but to humanity's next chapter. The sterile hum of NASA's Planetary Defense Coordination Office in October 2025 feels like the antechamber to a momentous event. On the vast projection screens, the blinding disk of our sun dominates, and somewhere behind it, hidden from our most powerful instruments, is 3I Atlas. You see the urgent coordinated activity of the IAWN, the International Asteroid Warning Network, normally activated for threats, not for comets. This isn't just about observation, it's about preparation. Consider NASA's DART mission, the Double Asteroid Redirection Test, which successfully impacted an asteroid moonlet, Dimorphos, in September 2022. It was hailed as a triumph of planetary defense, proving humanity's ability to subtly alter the trajectory of a celestial body. But what if it was more than that? What if DART was a dry run, a rehearsal not just for a hypothetical asteroid threat, but for a far more nuanced existential scenario? Imagine the strategic intelligence of a civilization observing us. They would watch our defensive capabilities. They would analyze our response to a perceived threat, whether natural or otherwise. A mission like DART, broadcast globally, demonstrating our capacity for precision impact and orbital alteration, provides invaluable data. It shows we can defend ourselves, but also that we are a species capable of sophisticated engineering and, crucially, of coordinated global action. This then becomes another layer in the unfolding arrival protocol. The fragment, IM-1, probes our planetary resilience. The scout, Oumuamua, tests our detection. The probe, Borisov, assesses our scientific interpretation. The delegation, 3I Atlas, arrives with unmistakable artificiality. And our own DART mission, a public display of our capabilities, provides precisely the data and advanced intelligence would need to understand our defensive posture and technological readiness. The universe, it seems, has been observing our rehearsals for contact, learning about our strengths and our vulnerabilities, long before we understood the game was even being played. And now, behind the sun, a definitive play is underway. What new set of rules will emerge with the reappearance of 3I Atlas? The Deep Space Listening Station is silent, not with the static of an empty channel, but with the profound absence of expected communication. You are here, in the nerve center of SETI, surrounded by screens displaying radio noise, searching for a pattern, a signal, a whisper from across the light years. Humanity sent its golden record, its cosmic invitation, expecting a reply in kind, a burst of organized radio waves, a mathematical sequence, a decoded message. But what if the conversation isn't being conducted through electromagnetic waves at all, What if it's being conducted through matter, through presence, through an intricate sequence of physical visits? Consider the 3 interstellar objects, now 4 if we count IM-1, not as random celestial phenomena, but as carefully crafted statements in a dialogue. IM-1, the precursor whose impossible material strength spoke of manufacture, not nature. It was an initial, almost subliminal declaration of presence. Then Oumuamua, the scout, arriving precisely 40 years after Voyager's launch, exhibiting physics-defying acceleration. Its message, "We are here, we can observe you. Can you perceive us when we defy your known physics?" A test of our scientific paradigm. Next, 2I Borisov, the probe, 2 years later. Appearing perfectly natural, a textbook comet, its silent query, "Having seen our anomaly, how do you interpret normalcy? Do you question what you think you know, or retreat to comfortable explanations?" It was a profound test of our intellectual humility, our willingness to look beyond the obvious. It learned not just our instruments, but our biases. And now, 3I Atlas, the colossal Manhattan-sized delegation, overtly displaying industrial nickel signatures and actively maneuvering with an anti-solar tail. Its statement is undeniable. We are here, we are intelligent, and we are engaging on a scale you cannot ignore. This isn't just a series of objects. It's an escalating exchange, a non-verbal language unfolding in real time across the vastness of our solar system. The questions they have asked through their behavior have been answered by our reactions, our scientific debates, our planetary defense drills. And the next, most potent part of this cosmic conversation begins behind our sun, hidden, silent, and entirely beyond our immediate perception. What, you wonder, is the final word in this profound, silent dialogue? The silence in the SETI control room is not empty, but pregnant with anticipation. The banks of computers, usually sifting through cosmic static for intelligent signals, are now cross-referencing astronomical data with hypothetical contact scenarios. It's October 29th, 2025. 3I Atlas has vanished behind the sun. You feel a profound shift in the air. The search for intelligent life is no longer abstract, but intensely, viscerally present. The question isn't if they are listening, but how they are choosing to speak. Advanced civilizations, if they exist, would not approach a younger species with haphazard or threatening gestures. They would adhere to a first contact protocol, a carefully considered sequence designed to minimize shock, gather intelligence, and ultimately facilitate understanding. You visualize the unfolding narrative. The initial fragment, IM-1, 2014, an incredibly tough engineered object that impacted Earth. A nearly missed data point, but now a subtle probe of our planetary defenses and material science. The Scout. Oumuamua, 2017, physics-defying acceleration, a bizarre shape. Its mission, test our detection capabilities, our observational limits. Did we see it? Yes. Did we understand it? No. The Probe. 2I Borisov, 2019, seemingly normal, a textbook comet. Its mission, observe our scientific methods, our biases, how we interpret the familiar. It learned our intellectual landscape. The Delegation. 3I Atlas, 2025. Manhattan-sized industrial nickel signatures, active maneuvering, and a deliberate disappearance behind our sun at perihelion. Its mission, to deploy, to position, to prepare for overt engagement using our own star as a veil. This systematic escalation from barely noticed engineered fragments to a colossal, actively controlled presence aligns perfectly with how a mature civilization would approach first contact. They wouldn't land on the White House lawn, sparking panic and potential conflict. Instead, they would gather intelligence, assess risk, and demonstrate their capabilities in a graduated, controlled manner, allowing us time to process the increasing anomalies. The timing, the size escalation, the anomalous behaviors. These are not coincidences. They are deliberate steps in an alien protocol. And the next step in this profound exchange is about to be revealed. The silence behind the sun is not a void. It is a stage where the grand unveiling is already underway. The blinding disk of the sun dominates your vision, a celestial shield behind which 3i Atlas has vanished. You are in a secure facility, surrounded by a cascade of data, each piece contributing to a mosaic of anomalies. The air itself feels thick with the weight of unanswered questions, and the palpable tension of this moment, October 29th, 2025, forces a re-evaluation of everything we thought we knew about our place in the cosmos. It's no longer about a single strange object. It's about a pattern and its undeniable implications. You sift through the dossier of these interstellar visitors, each entry a puzzle. First, IM-1 from 2014. A small, tough meteor whose industrial nickel signature and impossible material strength whispered of engineering, not nature. It was our first hint, almost missed, a subtle probe of our planet's resilience. Then the brazen anomaly of Oumuamua in 2017. Cigar-shaped, accelerating inexplicably without propulsion, defying every known law of cometary physics. Many dismissed it, but its very strangeness, appearing exactly 40 years after Voyager's launch, demanded a more radical interpretation. A scout, testing our ability to even perceive the truly alien. Next, 2i Borisov in 2019, a kilometer-wide visitor outwardly normal, a textbook comet. Its placid appearance following so soon after Oumuamua seemed to offer a comforting return to the familiar. But what if its normalcy was a deliberate camouflage? A probe, meticulously observing our scientific methods, our biases, our capacity for skepticism, while gathering intelligence on how we analyze the universe. Now 3i Atlas in 2025. Manhattan-sized, 33 billion tons, overtly releasing industrial nickel vapor, actively maneuvering with an anti-solar tail, and crucially, performing a strategic disappearing act behind our sun. This is not coincidence. Individually, each might be explained away as an exotic natural phenomenon, but synthesized, viewed as a complete narrative. They form an escalating sequence, an engineered fragment, a physics-defying scout, a camouflaged probe, and now a monumental delegation. The data points no longer contradict. They cohere into a chillingly logical arrival protocol. An intelligence has been systematically observing, assessing, and preparing for engagement. And the next, most profound stage of this unfolding first contact is currently hidden, shielded by our own star. What new reality, what new set of rules will emerge from that solar conjunction? The silence holds its breath. The air in the NASA Planetary Defense Coordination Office still hums with the electric tension of October 29th, 2025. On the main monitor, where 3i Atlas once tracked its deliberate path, now only the blinding disk of the sun glows. You feel the weight of its absence, the profound helplessness of being unable to observe what truly transpires behind that celestial shield. But even in this blind spot, Professor Avi Loeb's analysis offers a chilling probability. He is not alone in his conclusions, but he is certainly the most vocal, and perhaps the most prescient. Loeb assigned a 30-40% probability of Oumuamua being artificial, a number considered audacious, even heretical, by many in the mainstream scientific community at the time. Yet he insisted that when all natural explanations for an object's anomalous behavior fail, the scientific method demands consideration of an artificial origin. You recall the dismissal, the academic scorn, the comfort in clinging to increasingly convoluted naturalistic theories. But now, with 3i Atlas, Manhattan-sized, spewing industrial nickel, actively maneuvering with an anti-solar tail, and deliberately disappearing behind our star, how do those probabilities shift? If Oumuamua was 30–40% likely to be artificial, what number would encompass the entirety of this escalating systematic arrival protocol? The fragments of IM-1, the scouting behavior of Oumuamua, the deceptive normalcy of 2i Borisov, and now the monumental engineered presence of Atlas. Each anomaly, when synthesized, increases the probability not just of artificiality, but of deliberate intelligent contact. This isn't about proving aliens, not yet. It's about rigorously following the evidence, even when it leads to uncomfortable, paradigm-shattering conclusions. It's about asking the hardest questions when the data demands it. Most scientists, even now, cling to the comet narrative for 3i Atlas, preferring the known, however stretched, to the truly unknown. But the tension in the room, the activated planetary defense systems, the quiet urgency tell a different story. They reveal a deeply unsettling awareness of an alternative explanation, one that, in the face of so much accumulated evidence, becomes increasingly difficult to dismiss. What, you ponder, will be the true cost of our skepticism if Avi Loeb's 40% solution was merely the beginning? You stand at the window of your own home, perhaps in a quiet suburban backyard, or a city apartment with a sliver of sky visible between buildings. The October night air is cool against your skin. Above, the stars begin to emerge, distant, indifferent, yet suddenly brimming with a new, profound significance. It is October 29th, 2025. Somewhere up there, shielded by the blinding protective disk of our sun, a Manhattan-sized object of undeniable artificiality is performing its secret work. This isn't ancient history. This is now. This is a moment of contemplative urgency, for humanity's cosmic loneliness may be drawing to an end. The weight of 48 years of silence, punctuated by a series of increasingly anomalous visitors, presses down. From the industrial nickel of IM-1 to the impossible acceleration of Oumuamua, to the disguised scrutiny of 2i Borisov, and now the colossal, actively maneuvering 3i Atlas. Each a step in an unfolding protocol, a deliberate response to our audacious cosmic invitation. This isn't invasion. This is a meticulously planned first contact, an engagement strategy mirroring how a mature civilization might cautiously approach a younger one. The implications are civilization altering. If we are indeed standing at the precipice of first contact, what does it mean for our place in the universe? For our understanding of life, of physics, of our own potential? The questions are unanswered, hanging heavy in the cool night air. Is this benevolence, curiosity, a cosmic handshake, or something far more complex? The answers for now remain shrouded behind the sun, locked within the silent actions of 3i Atlas. By the time the sun releases its secret, the world will have changed. The very concept of alone in the universe may become a relic of a bygone era. You look up, searching for the familiar constellations, but your mind is drawn to the invisible spot where Atlas hides. You are part of this moment, a witness to history as it happens. And whether the revelation is subtle or spectacular, Whether it confirms our hopes or challenges our fears, humanity's next chapter has already begun. The silence between the stars, for so long our companion, may soon break forever. The silence is no longer merely cosmic. It has become intellectual, a heavy weight in the sterile glow of the research lab. It is October 29th, 2025, and though 3I Atlas is hidden, the implications of its presence are starkly visible on the faces of the scientists around you. They grapple not just with new data, but with the profound, unsettling reality that our universe might be far more populated and far more deliberate than they ever dared to acknowledge. This is the burden of first knowledge, the struggle to accept what the evidence implies when it shatters deeply held beliefs. You revisit the cumulative evidence, the impossible material strength of IM-1, found scattered years before any interstellar object was officially recognized. The inexplicable acceleration of Oumuamua, a phantom limb of propulsion that mocked our physics. The deceptive normalcy of 2I Borisov, a perfectly camouflaged spy studying our gaze. And now the colossal Manhattan-sized 3I Atlas, overtly displaying industrial nickel, actively maneuvering and strategically vanishing behind the sun. Each piece, on its own, a fascinating anomaly. Combined, they form a narrative too coherent, too systematic, to be mere cosmic coincidence. This is the tension that Werner Herzog often finds in the unknowable, the raw, visceral human reaction to something that defies all rational framework, yet undeniably is. The loneliness of those few voices like Professor Avi Loeb, who dared to suggest an artificial origin early on, now echoes with a tragic prescience. To be right when everyone dismisses you is a profound isolation. Now the weight of that truth presses on everyone. This isn't theoretical. It's unfolding history, demanding a profound re-evaluation of humanity's uniqueness in the cosmos. What does it mean to be the generation that stands on the cusp of true first contact? Not a distant signal, but a physical presence. It means confronting our deepest assumptions, our scientific dogma, and our place in a universe that might be less empty and more intentional than we ever imagined. The sun shields its secret now, but the questions it raises illuminate a new dawn. The blinding glare of the sun has swallowed 3I Atlas, leaving the mission control room at NASA JPL in a state of suspended animation. It's October 29th, 2025. You feel the collective breath held, the unspoken question hanging heavy in the air. We are blind. And in this darkness, the pattern, the sequence of interstellar visitors, speaks to a logic far beyond random celestial mechanics. This isn't coincidence. This is a message, encoded not in signals, but in the deliberate maneuvers and escalating anomalies of physical objects. Consider the trajectory of each object not just as a path through space, but as a carefully constructed sentence in a cosmic language. I am one, the fragment of impossible material strength, arriving first in 2014. Its message, we are here subtly, in forms you don't yet recognize as artificial. Then, Oumuamua in 2017 with its physics-defying acceleration, its message, we are here, overtly anomalous, challenging your scientific frameworks. Next, 2I Borisov in 2019, disguised as a natural comet. Its message, we are here, observing your observational biases, understanding your interpretations of the natural world. And now, 3I Atlas in 2025, Manhattan-sized, spewing industrial nickel, actively maneuvering with an anti-solar tail and executing a strategic perihelion maneuver behind the sun. Its message is the most profound yet. We are here with a presence you cannot ignore, positioning for a new phase of engagement, unseen but deliberate. The very act of hiding behind the sun isn't a passive event. It's an active statement of intent, a calculated move to control the terms of engagement, to choose the moment and method of its reveal. These are not just objects. They are expressions of a protocol, each designed to elicit a specific response, to gather specific intelligence, to prepare for a moment like this. The meticulous planning, the patience spanning decades, the escalating scale and anomalous behavior, it all speaks to an intelligence that understands both physics and psychology. They are communicating through their presence, their actions, their very nature. And the most significant part of that message is now unfolding in the silent, blazing darkness behind our star. We are no longer passively searching for a signal. We are actively being engaged by a physical manifestation of an alien intelligence. What, you wonder, will be the next word in this silent, cosmic conversation? When 3i Atlas re-emerges from the sun's embrace, the central monitor in the otherwise dark research lab glows with a stark orange circle, our sun. Somewhere behind its blinding disk, 3i Atlas continues its unseen work, a colossal silence that hums with profound possibility. It is October 29th, 2025. You review the composite plot, a tapestry woven from the trajectories of 3 interstellar visitors, now a chillingly precise sequence of movements. These aren't just paths through space, they are statements, a non-verbal language unfolding across decades, designed for maximum impact and intelligence gathering. First, recall IM-1 from 2014. Its trajectory was undeniably hyperbolic, confirming its interstellar origin, but it was its extreme material toughness and industrial nickel composition that truly spoke volumes, a physical calling card of advanced engineering. This was a direct, albeit unnoticed, probe of our planet's resilience. Then the elegant yet perplexing arc of Oumuamua in 2017. Its hyperbolic path was compounded by inexplicable non-gravitational acceleration. This wasn't merely a cosmic visitor, its movement defied the very physics we understood, a deliberate choice of propulsion that forced us to question our assumptions. Its trajectory was a test of our scientific perception, a challenge to our paradigm. Next, in 2019, 2I Borisov's trajectory appeared perfectly normal, a textbook comet. But in the context of Oumuamua's strangeness, this normalcy became the anomaly. Its path was designed to not stand out, allowing it to move unimpeded, studying our observation methods, our biases, our instruments. Its trajectory was a lesson in camouflage, a silent collection of intelligence on our interpretive faculties. And now, 3i Atlas. Its colossal mass follows a hyperbolic path, but its anti-solar tail and its current, precise perihelion alignment behind our sunscreen of active, intelligent control. This trajectory is a tactical maneuver, a strategic deployment. It is choosing to use our own star as a cloak, a temporary sanctuary for whatever critical operations are unfolding. The convergence of these distinct orbital behaviors, from tough fragment to physics-defying scout, to camouflaged probe, to actively maneuvering delegation, tells us a story of escalating intent. This isn't random. It's a meticulously crafted narrative of approach. The silence between stars is not merely an absence of sound, but a canvas upon which a profound, deliberate message is being written through movement. When 3i Atlas reemerges, its final trajectory may well be the most eloquent statement of all. The cool air of October 29th, 2025 settles around you. The sun, a blinding circle of fire, has just swallowed 3I Atlas, removing it from human observation, but the silence that follows is not peaceful. It is heavy with anticipation, a cosmic breath held collectively across Earth. You stand on the precipice of a new reality, gazing into the profound depth of the unknown. The implications of this unfolding protocol are not just scientific, they are deeply philosophical, touching the very core of what it means to be human in an immense, potentially populated universe. For generations, the question, "Are we alone?" has defined our cosmic perspective. It has been a lonely quest, sustained by audacious hope, etched onto golden records and beamed into the void. Now, as 3I Atlas performs its unseen work behind our star, the question subtly shifts. It is no longer, "Are we alone?" but "Are they listening, and what do they want?" This is the moment Carl Sagan dreamed of, and perhaps also feared. The evidence points to a deliberate, methodical approach. It speaks of a civilization that is patient, strategic, and deeply intelligent. They have observed us, assessed our capabilities, understood our scientific biases. They have chosen a subtle, escalating form of engagement, avoiding the shock of a direct, overt landing. This is not invasion. It is a meticulously managed introduction, a respectful, or perhaps merely pragmatic, overture. The implications for humanity are monumental. Our cosmic loneliness, a profound cultural touchstone, may be dissolving. We are being asked to grapple with the knowledge that we may not be the sole custodians of intelligence, that our scientific models might be incomplete, and that our future may now be intertwined with a presence from beyond the stars. This is history being written in real time, unfolding not just in the data streams of distant observatories, but in the quiet contemplation of every individual looking up at the veiled sun. The questions are unanswered. The tension is palpable. But the possibilities, both exhilarating and terrifying, have just begun to awaken. You stand on a precipice, not of a mountain, but of human history. The October 29th, 2025 sun, now a blinding shield, conceals 3E Atlas. But it reveals something profound about us. The very air around you feels charged with an unspoken understanding. We, as a species, are on the threshold. The narrative woven by IM-1, Oumuamua, 2I Borisov, and now Atlas, forces a synthesis, a realization that transcends individual scientific anomalies and speaks to a grand, deliberate cosmic ballet. This isn't an invasion scenario of Hollywood fiction. There are no saucers landing on the White House lawn. Instead, there is a patient, systematic approach, an arrival protocol that speaks to an intelligence far beyond our own, yet disturbingly familiar in its logic. You imagine a species capable of interstellar travel, operating with a wisdom born of eons. How would they approach a younger, broadcasting civilization? Not with a jarring shout, but with a cautious whisper, escalating to a measured declaration. The 40-year window from Voyager's launch to Oumuamua's arrival. The perfectly timed sequence of scout, probe, and delegation. The increasing scale and undeniable artificiality. These are the hallmarks of intelligent design. They observed our technological capabilities through Oumuamua's anomaly and our interpretive biases through Borisov's normalcy. They even probed our planet's resilience with a tough metallic fragment years prior. Now with Atlas, they are positioning for a more direct, yet still controlled revelation. Humanity, the species that once pondered its profound loneliness against the backdrop of the pale blue dot, now stands at the edge of that very solitude. The questions are immense, civilization-altering, touching upon our place in the cosmos, our understanding of life itself. We are not just observing history, we are living it, breathing it. The tension is palpable, the uncertainty terrifying, but beneath it all, a profound wonder stirs. The silence behind the sun is not a void, but a prelude. And what emerges from that silence will redefine everything. The control room is quiet, bathed in the soft glow of monitors. The air thick with the unspoken gravity of October 29th, 2025. You are among the silent watchers, staring at a blank screen where 3i Atlas once was, now hidden behind the sun's incandescent shield. This is not the silence of an empty universe, but the pregnant hush before a profound revelation. The accumulated evidence, synthesized into a cohesive narrative, suggests that humanity stands on the cusp of something unprecedented. This isn't an invasion narrative, it's something far more subtle, more patient. It's a first contact etiquette, meticulously observed by an intelligence that understands discretion and strategy. You imagine the immense wisdom required to orchestrate such an arrival protocol. Advanced civilizations, far from being primitive aggressors, would likely prioritize careful assessment and a gradual reveal. Landing on the White House lawn would be chaotic, destructive. Instead, they choose a calibrated, escalating series of engagements designed to gather intelligence and prepare the target species. The 40-year timeline from Voyager's launch to Oumuamua's arrival is not a coincidence, but a precision calculation, a travel time from a nearby star system, the size escalation from the small scout Oumuamua to the kilometer-wide probe Borisov to the Manhattan-sized delegation 3i Atlas is a deliberate statement of increasing presence and capability. Each step of the protocol, from the initial, almost missed engineered fragment, IM-1, to the current hidden deployment, serves to gather data on our technology, our science, our psychological responses, our capacity for both belief and skepticism. They have studied us meticulously. They know how we detect, how we interpret, how we react to the anomalous and the seemingly normal. And now, behind the sun, the final stage of this long, patient approach is unfolding. This isn't about threat. It's about encounter. It's about a shift in the cosmic balance, an end to our perceived solitude. The questions are unanswered, the future unknown. But the implications are undeniable. Humanity is no longer asking if it's alone. We are waiting for the next move from an intelligence that has been listening and is now finally ready to respond. The silence in the mission control room is thick, not just with the hum of electronics, but with the profound collective tension of a species holding its breath. It is October 29th, 2025. You are watching a blank screen, a searing white circle representing our sun, and behind it, utterly hidden from our view, is 3i Atlas. This is the moment of perihelion, its closest approach to our star, and simultaneously, the perfect solar conjunction, our cosmic blind spot. This isn't a passive hiding, this is a deliberate strategic maneuver chosen for maximum tactical advantage. The perihelion offers an immense gravitational assist, an Oberth maneuver, allowing the Manhattan-sized object to gain velocity with extraordinary efficiency. But for a vessel that has already demonstrated industrial signatures and active steering, this window behind the sun is more than just an efficient route. It's a deployment zone. You imagine what could be unfolding in that blazing darkness, shielded from every telescope on Earth and in orbit. A mothership, perhaps, deploying a swarm of mini-probes, small autonomous craft, slingshotting around the sun, using its immense gravity to scatter across our solar system. Their mission, a far more detailed, intimate reconnaissance of our planets, our moon, our orbital infrastructure. They would be ghost-like, a silent network of eyes and ears, extending the intelligence-gathering phase from the delegation into myriad unseen observations. This is the logical next step in the arrival protocol. The fragment probed our planet. The scout tested our perception. The probe assessed our interpretation. The delegation 3-eye atlas, with its unmistakable artificiality, now utilizes our star itself for its next, most crucial phase. The silence from behind the sun isn't an absence of activity. It's a profound, terrifying moment of unseen creation. We are left to stare at the blinding light, knowing that whatever new reality emerges from its embrace is being forged right now in the dark. The countdown continues, not just for Atlas to reappear, but for humanity to truly face the profound, unsettling implications of its guests. The raw, unfiltered image of our sun, a scorching orb of hydrogen fusion, dominates the primary display in the Mission Control Center. It's October 29th, 2225. You feel the immense, almost physical heat radiating from the projected image, even as the room's climate control keeps the air crisp and cool. Somewhere behind that blinding disk, 3-eye Atlas, the Manhattan-sized emissary from beyond our stars, is now completely hidden from our telescopic gaze. This is the heart of the crisis moment, the strategic deployment window that astronomers like Avi Loeb had anticipated with such a mix of dread and exhilaration. This isn't merely a perihelion, a closest approach to the sun. For any engineered craft, this is the prime opportunity for an Oberth maneuver, an unparalleled gravitational assist that maximizes velocity with minimal fuel expenditure. But for an object already demonstrating industrial nickel signatures and active maneuvering with an anti-solar tail, this particular perihelion, coinciding with a total solar conjunction, is a masterclass in tactical concealment. It's the perfect staging ground. You imagine what could be unfolding in that unreachable, brilliant dark. A colossal mothership shielded from our prying eyes now has the cover to initiate its most critical operations. Perhaps it's deploying a vast swarm of smaller probes, each no bigger than a car or even a smartphone. These mini probes, launched during the gravitational slingshot, could then be flung across our entire solar system with incredible efficiency and precision. Their mission: a detailed granular reconnaissance of our inner planets, our moon, our orbital space. They would be ghosts in the machine of our solar system, silently gathering intelligence, expanding the reach of the alien delegation into every corner of our cosmic neighborhood. This is the logical culmination of the arrival protocol. Having tested our perception, assessed our science, and now masked its intentions, the delegating intelligence is taking its next, most profound step. The silence isn't empty, it's a profound moment of unseen creation, a quiet reshaping of our immediate cosmos. For these crucial days, humanity remains blind, staring at the radiant shield of our own star, knowing that whatever new reality emerges from its embrace is being born right now, in the depths of that inaccessible glare. We are passive witnesses to a cosmic event, the implications of which we can only begin to grasp. The late October wind whispers around your home, carrying the crisp scent of autumn. The stars, now free from the sun's blinding glare, seem to twinkle with a new, knowing light. It is no longer October 29th, 2025. It is the dawn of the 30th. You stand at your window looking up, knowing that the blinding solar conjunction has passed. Somewhere out there, no longer hidden, Three-Eye Atlas has emerged. What did it do in the dark? What now awaits discovery? We don't yet know what happened with absolute certainty, but we will soon. The watch, the frantic search for new data, has only just begun. 48 years ago, your grandparents' generation sent a golden invitation into the vast cosmic ocean aboard Voyager 1. A message full of the sounds and images of Earth, asking, "Are we alone?" For decades, silence. Then a series of echoes, physical responses that have escalated in size and defiance of our understanding. I am one, the impossibly tough metallic fragment. Oumuamua, the physics-defying scout. 2I Borisov, the perfectly camouflaged probe. Each a carefully measured statement in a silent cosmic dialogue. And now 3I Atlas, a Manhattan-sized monolith of engineered nickel, actively maneuvering, performing a tactical disappearance behind our star. Its re-emergence from that solar blind spot, whether it unveils a fleet of mini probes or simply continues its hyperbolic trajectory, will confirm or refute the most audacious hypothesis in human history. Is this humanity's first contact with extraterrestrial intelligence? Or the most elaborate, statistically improbable, cosmic coincidence ever conceived? The evidence, when synthesized, leans heavily towards the former. The timing is too perfect, the escalation too systematic. Scout, probe, delegation. This feels like protocol. You are living through this history right now. The profound wonder at our place in the universe. The loneliness of being the only intelligent species we know. These concepts are being rewritten. This moment is both terrifying in its uncertainty and exhilarating in its potential. By the time the full data from Atlas's re-emergence is collected and analyzed in the coming weeks and months, the very fabric of our understanding may have changed forever. We dared to ask the question, and the terrifying, exhilarating possibility is that after 48 years of waiting, someone is finally answering. The silence between stars is about to break. Or perhaps it already has, and we just haven't heard the full reply.